Greetings. You're listening to Big Ideas Simply Explained, the Math Book. You're listening to World Reading Club, presented by Hakeem Alibokis Alexander, here on Spreaker, social podcasting by iHeartMedia. Presented for World Reading Club in association with Uniquilibrium. This edition's reading focus comes to us from Big Ideas Simply Explained, the Math Book, and is titled Introduction. We're going to read a long introduction here. So get ready for some hands-free reading as we get ready to set off here. There's a nice long introduction. On my Hakeem Alexander podcast, I had already read the foreword, and so you can check that out if you want. A lot of these readings are going to be in various different places around the web now. I have various different websites. So there's a plan that I have now about what I'm going to be doing. So that's going to be something you'll be able to check out. Various different. So yeah, you'll be able to check that out. And know that they'll be available for you in various different places for you to see. This is the first of these here. I'm going to go through the math book, the physics book, and biology. And I have another treat, which is chemistry. Although Big Ideas Simply Explained does not have a chemistry edition, so far as I know, I'm going to be using the Cartoon Guide to Chemistry by Larry Gonick to start doing a reading for World Reading Club about chemistry. This is exciting. We're going to learn so much together and be able to move forward with our understanding of the subject. So let's get started right away. Big Ideas Simply Explained, the Math Book, Introduction. The history of mathematics reaches back to prehistory, when early humans found ways to count and quantify things. In doing so, they began to identify certain patterns and rules in the concepts of numbers, sizes, and shapes. They discovered the basic principles of addition and subtraction. For example, that two things, whether pebbles, berries, or mammoths, when added to another two, invariably resulted in four things. While such ideas may seem obvious to us today, they were profound insights for their time. They also demonstrate that the history of mathematics is, above all, a story of discovery rather than invention. Although it was human curiosity and intuition that recognized the underlying principles of mathematics, and human ingenuity that later provided various means of recording and notating them, these principles themselves are not a human invention. The fact that 2 plus 2 equals 4 is true, independent of human existence, the rules of mathematics, like the laws of physics, are universal, eternal, and unchanging. When mathematics first showed that the angles of any triangle in a flat plane, when added together, come to 180 degrees, a straight line, this was not their invention. They had simply discovered a fact that had always been, and will always be, true. Early applications. The process of mathematical discovery began in prehistoric times, with the development of ways of counting things people needed to quantify. At its simplest, this was done by cutting tally marks in a bone. or stick, a rudimentary but reliable means of recording numbers of things. In time, words and symbols were assigned to the numbers, and the first systems of numerals began to evolve. A means of expressing operations such as acquisition of additional items or depletion of a stock, the basic operations of arithmetic. As hunter-gatherers turned to trade and farming and societies became more sophisticated, arithmetical operations and a numerical system became essential tools in all kinds of transactions. To enable trade, stock-taking, and taxes in uncountable goods such as oil, flour, or plots of land, systems of measurement were developed, putting a numerical value on dimensions such as weight and length. Calculations also became more complex, developing the concepts of multiplication and division from addition and subtraction, allowing the area of land to be calculated. For example, in the early civilizations, these new discoveries in mathematics, and specifically the measurement of objects in space, became the foundation of the field of geometry. Knowledge that could be used in building and tool-making. In using these measurements for practical purposes, people found that certain patterns were emerging, which could in turn prove useful. A simple but accurate carpenter square can be made from a triangle with sides of 3, 4, and 5 units. Without that accurate tool and knowledge, the roads, canals, ziggurats, and pyramids of ancient Mesopotamia and Egypt could not have been built. As new applications for these mathematical discoveries were found in astronomy, navigation, engineering, bookkeeping, taxation, and so on, further patterns and ideas emerged. The ancient civilizations each established the foundations of mathematics through this interdependent process of application and discovery, but also developed a fascination with mathematics for its own sake, so-called pure mathematics. From the middle of the first millennium BCE, the first pure mathematicians began to appear in Greece, and slightly later in India and China, building on the legacy of the practical pioneers of the subject, the engineers, astronomers, and explorers of earlier civilizations. Although these early mathematicians were not so concerned with the practical applications of their discoveries, they did not restrict their studies to mathematics alone. In their exploration of the properties of numbers, shapes, and processes, they discovered universal rules and patterns that raised metaphysical questions about the nature of the cosmos, and even suggested that these patterns had mystical properties. Often, mathematics was therefore seen as a complementary discipline to philosophy. Many of the greatest mathematicians through the ages have also been philosophers, and vice versa, and the links between the two subjects have persisted to the present day. Quote, "It is impossible to be a mathematician without being a poet of the soul." Sofia Kovalevskaya, Russian mathematician. Again, it is impossible to be a mathematician without being a poet of the soul. Sofia Kovalevskaya, Russian mathematician. Quote, "Geometry is knowledge of the eternally existent." Pythagoras, ancient Greek mathematician. Geometry is knowledge of the eternally existent. Pythagoras, ancient Greek mathematician. Arithmetic and algebra. So began the history of mathematics as we understand it today. The discoveries, conjectures, and insights of mathematicians that form the bulk of this book, as well as the individual thinkers and their ideas. It is a story of societies and cultures, a continuously developing thread of thought from the ancient civilizations of Mesopotamia and Egypt through Greece, China, India, and the Islamic Empire to Renaissance Europe and into the modern world. As it evolved, mathematics was also seen to comprise several distinct but interconnected fields of study. The first field to emerge, and in many ways the most fundamental, is the study of numbers and quantities, which we now call arithmetic, from the Greek word arithmos, number. At its most basic, it is concerned with counting and assigning numerical values to things, but also the operations such as addition, subtraction, multiplication, and division that can be applied to numbers. From the simple concept of a system of numbers comes the study of the properties of numbers, and even the study of the very concept itself. Certain numbers, such as the constants pi, Euler's number, or the prime and irrational numbers, hold a special fascination and have become the subject of considerable study. Another major field in mathematics is algebra, which is the study of structure, the way that mathematics is organized, and therefore has some relevance in every other field. What marks algebra from arithmetic is the use of symbols, such as letters, to represent variables, unknown numbers. In its basic form, algebra is the study of the underlying rules of how those symbols are used in mathematics, in equations, for example. Methods of solving equations, even quite complex quadratic equations, had been discovered as early as the ancient Babylonians, but it was medieval mathematicians of the Islamic Golden Age who pioneered the use of symbols to simplify the process, giving us the word algebra, which is derived from the Arabic al-jabr. More recent developments in algebra have extended the idea of abstraction into the study of algebraic structure known as abstract algebra. Quote, "In mathematics, the art of asking questions is more valuable than solving problems." George Cantor, German mathematician. Repeating, "In mathematics, the art of asking questions is more valuable than solving problems." George Cantor, German mathematician. Geometry and calculus. A third major field of mathematics, geometry, is concerned with the concept of space and the relationships of objects in space, the study of the shape, size, and position of figures. It evolved from the very practical business of describing the physical dimensions of things. In engineering and construction projects, measuring and apportioning plots of land, and astronomical observations for navigation and compiling calendars. A particular branch of geometry, trigonometry, the study of the properties of triangles, proved to be especially useful in these pursuits. Perhaps because of its very concrete nature, for many ancient civilizations, geometry was the cornerstone of mathematics, and provided a means of problem-solving and proof in other fields. This was particularly true of ancient Greece, where geometry and mathematics were virtually synonymous. The legacy of great mathematical philosophers such as Pythagoras, Plato, and Aristotle was consolidated by Euclid, whose principles of mathematics, based on a combination of geometry and logic, were accepted as the subject's foundation for some 2,000 years. In the 1800s, however, alternatives to classical Euclidean geometry were proposed, opening up new areas of study, including topology, which examines the nature of properties not only of objects in space, but of space itself. Since the classical period, mathematics had been concerned with static situations, or how things are at any given moment. It failed to offer a means of measuring or calculating continuous change. Calculus, developed independently by Gottfried Leibniz and Isaac Newton in the 1600s, provided an answer to this problem. The two branches of calculus, integral and differential, offered a method of analyzing such things as the slope of curves on a graph and the area beneath them as a way of describing and calculating change. The discovery of calculus opened up a field of analysis that later became particularly relevant to, for example, the theories of quantum mechanics and chaos theory in the 1900s. Revisiting logic. The late 19th and early 20th centuries saw the emergence of another field of mathematics, the foundations of mathematics. This revived the link between philosophy and mathematics. Just as Euclid had done in the 3rd century BCE, scholars including Gottlieb Frege and Bertrand Russell sought to discover the logical foundations on which mathematical principles are based. Their work inspired a re-examination of the nature of mathematics itself, how it works, and what its limits are. This study of basic mathematical concepts is perhaps the most abstract field, a sort of meta-mathematics, yet an essential adjunct to every other field of modern mathematics. New technology, new ideas. The various fields of mathematics, arithmetic, algebra, geometry, calculus, and foundations, are worthy of study for their own sake. And the popular image of academic mathematics is that of an almost incomprehensible abstraction. But applications for mathematical discoveries have usually been found, and advances in science and technology have driven innovations in mathematical thinking. A prime example is the symbiotic relationship between mathematics and computers. Originally developed as a mathematical means of doing the donkey work of calculation to provide tables for mathematicians, astronomers, and so on, the actual construction of computers required new mathematical thinking. It was mathematicians, as much as engineers, who provided the means of building mechanical and then electronic computing devices, which in turn could be used as tools in the discovery of new mathematical ideas. No doubt, new applications for mathematical theorems will be found in the future too. And with numerous problems still unsolved, it seems that there is no end to the mathematical discoveries to be made. The story of mathematics is one of exploration of these different fields and the discovery of new ones, but it is also the story of the explorers, the mathematicians who set out with a definite aim in mind to find answers to unsolved problems or to travel into unknown territory in search of new ideas, and those who simply stumbled upon the idea in the course of their mathematical journey and were inspired to see where it would lead. Sometimes the discovery would come as a game-changing revelation, providing a way into unexplored fields. At other times, it was a case of standing on the shoulders of giants, developing the ideas of previous thinkers, or finding practical applications for them. This book presents many of the big ideas in mathematics, from the earliest discoveries to the present day, explaining them in layperson's language, where they came from, who discovered them, and what makes them significant. Some may be familiar, others less so. With an understanding of these ideas and an insight into the people and societies in which they were discovered, we can gain an appreciation of not only the ubiquity and usefulness of mathematics, but also the elegance and beauty that mathematicians find in the subject. Quote, "Mathematics, rightly viewed, possesses not only truth, but supreme beauty." Bertrand Russell, British philosopher and mathematician. Quote, "Mathematics, rightly viewed, possesses not only truth, but supreme beauty." Bertrand Russell, British philosopher and mathematician. You've been listening to World Reading Club, presented by Hakeem Alibokis Alexander, here on Spreaker, social podcasting by iHeartMedia, presented for World Reading Club in association with Uniquilibrium. Coming up next in the math book is Ancient and Classical Periods, 3500 BCE to 500 CE, from Big Ideas Simply Explained, the Math Book.